Okay, in this video we're going to go over rate of change and slope, which basically mean the same thing. Rate of change refers to how something is changing over time or as things go by. Rate of change basically will be involved in word problems. When I ask for slope, simply I'll just ask you to find the slope between 2 points or the slope of a graph. So in the first one, what we want to do is the blank is the difference in the y values of 2 points. Remember, slope is another way of saying rise over run. Okay? And that's y minus y over x minus x. Another way I've told you is delta y over delta x. That means change. The change in y over the change in x. When I say change, I'm also referring to the difference. So the blank is the difference in the y values. Well, if you notice, here's the y value, so that's the rise. So the rise is the change in the y, or the difference of the y values, whereas the run is the difference in the x values of 2 points in a line. Now, the slope of a line is the ratio of rise to run. So it's the ratio of the change in y over the change in x. So when I say ratio, I'm talking about this fraction right here. That's a ratio when you're comparing two items. Alright, so let's take a look at a graph. Alright, let's move this up a little bit. And let's take a look at this first one. It says find the rise and run between each set of points, then write the slope. Well, as you notice, I have here rise and run. So we're starting at this point. So we've gone up 1 unit, and we've gone to the right 1, 2, 3. So we're going to go over here. Let me erase this real quick. So we're going to go up 1 unit and 1, 2, 3 units to the right. So it's a rise of 1, a run of 3. So the change in y is 1, positive 1, and the change in x is 3. So you have a slope of 1/3. Now let's look at this next point. Again, we're going to start here at the bottom. We're going to go up 2. So that's a change in y of 2. And then we're going to continue. So like I said, up 2 and then to the right 1. So the change in x is 1. So it's a rise and run. So a rise of 2 and a run of 1. Now I would leave it as 2 over 1, especially when you're graphing. Or you can simply write 2, because 2 is understood to be 2 over 1. Alright, let's look, and I think that's it for that page. One last thing on this, notice that both of these, as we move from left to right, what's happening to the graph? It's increasing, so this is a positive slope. And again for this one, as we move from left to right, notice that the graph is increasing, so that's a positive slope. On this particular problem, I want you to pinpoint something. Notice as we go from left to right. So as we go from left to right, what's happening to the graph? It's decreasing, it's going down. So that means our answer, or our slope should be negative. So let me go ahead and erase that. And let's just investigate it a little bit more. Okay? Alright, so now let's pick out our rise and run. So here we go. Starting at the furthest left-hand point. Well, the rise, that means we're going to go down. So we're going to go 1, 2, 3. So we went down 3, so it was a rise of negative 3. Then, staying where we are, we're going to go to the right 1, 2 units. So it's a run of 2. So my change in y over my change in x. So it's a rise of negative 3 over a run of positive 2. That right there is a negative slope. So my rate of change is negative 3 over 2, or my slope is negative 3 over 2. Now, remember, it could be negative 3 over 2. That negative can be out front, or the negative can be on the bottom. It could be a 3 over negative 2. The reason I say that is because if you go back and double check, notice if I go up 1, 2, 3, I went up 3, and I go left 2. So again, my rise would be 3, my run would be negative 2. So either way, we're still going to get the same answer. all of these three are still the same. Okay, on this particular problem, what we want to do is tell whether the slope of each line is positive, negative, 0, or undefined. Now remember my little story. Okay? We're going to take a walk. First day of school, we have a positive attitude. We get to the top of the hill, we're so exhausted that we look down at the bottom of the hill and we start to walk down and we just get mad and angry, and you just have this negative attitude when you're walking down the hill because you've already walked 10 miles to school. Now remember, you get to the base of the hill and all of a sudden, you're just so tired that you just basically start sleepwalking. And that's where you start, the Z's, so that means 0. And then finally, you don't see the end of the road, you fall off, and basically it becomes undefined. So as you notice, some of the key elements from that story, a vertical line is undefined. When you have a horizontal line, that's going to be a 0 slope. And then of course you have your positive and negative. So if you look at number 7 relates to this story. So this is a 0 slope. Now look at number 8. Number 8 looks just like the negative, so therefore this is a negative slope. As we move from left to right, it goes down, so it's decreasing. And then if you look at number 9, this is a vertical line, which is very similar to this one right here. So this is going to be undefined. Okay, let's take a look at this problem. The table shows a truck driver's distance from home during one day's deliveries. Find the rate of change, so for each time interval. Now, in this case, remember, distance is going to depend on time. In other words, your distance from home will depend on how long you drive. So the more you drive, the further away from home you will be. Now, if you look at what we're going to do is we're going to look at the rate of change for each interval. Now, interval means like from hour 0 to hour 1. So from the hour 0 to hour 1. Well, that's a change of 1. Remember, these are your x's, these are your y's. So 0 to 35, well, that's a change of positive 35. So that ratio, or that rate of change, is 35 to 1. And that's what I'm going to put in the first blank. Okay, I'm going to put 35 over 1, or 35 to 1. Now look, the next one is 1 to hour 4. So from going from hour 1 to hour 4, that's a change of 3. But if you go from 35 to 71, now mind you, some of you can't do that in your head, so that's going to be about 36. So that'd be 71. So you end up getting 36 over 3. But what you have to realize is that this can be reduced, and you have to always look at your rate of change. So 36 over 3 happens to reduce down to 12 over 1. This is our ideal situation. That's what we want. Now look at hour 4 to hour 5. Hour 4 to hour 5, that's a change of 1. Well, to go from 71 to 82, that's 11. So this is going to be 11 to 1. So 11 miles. Now when it says rate of change, remember this is in miles and this is in hours. So 12 miles, 1 hour. I don't have enough room here, so I'm going to put 11 miles, 1 hour. Now from 5 to 8, that's a difference of 3 hours. Now to go from 82 to 199, if you don't have a calculator available, then what you might want to do is go back to your old way of subtracting. 9 minus 2 is 7. 19 minus 8 is 11, so 117. So that's going to be 117 to 3. So 117 to 3, so 117 miles in 3 hours. Now I wonder if that is reducible. Well, one way you can figure out is if you add up 7 plus 1 add up to 9. Well, 9 is divisible by 3. Well, you know what? That means 117 is also divisible by 3. So let me go ahead and erase all this so I can have more room to work. And what I'm going to do is I'm going to take that 117, I'm going to divide it by 3. 3 goes into 11 3 times, that's 9. Subtract, you get 2, bring down that 7. So 3 times 9 is 27, so that's 39. So now this is going to reduce to 39 miles in 1 hour. And then finally, 8 to 10, well that's 2. And 199 to 200 is a change of 1. So this is going to be 1 mile in 2 hours. Okay? 1 mile in 2 hours. Must have been a wreck or something. They didn't go very far. So 1 mile in 2 hours. So basically, what we can do there is we're going to get this down to 1 hour. So in 1 hour, how long did it take them to go 1 hour? Well, or how far did they go in 1 hour? Well, that means they went half a mile. So 0.5 miles in one hour. Could have been a traffic jam or so forth. Now, the rate of change represents the average speed for that time interval. So during which interval was the driver's average speed the smallest? Okay? So in this case, you need to look at all the time intervals and pick out which one is the smallest interval. So the last thing I've done for you is I went ahead and this is the first interval, second interval, third interval, fourth interval, and fifth interval. Out of all those, notice that this one is a half a mile in 1 hour. Whereas everyone else's was, the next lowest was 11 miles in 1 hour, 12 miles in 1 hour, 35 miles in 1 hour, and then 39 miles in 1 hour. So which one is really the smallest? Now, you didn't really go very far if you went half a mile in 1 hour.